Today, we're diving into a material that could, and I mean this, genuinely change the world. It's called Hempoxy, and it's designed to be strong, sustainable, and maybe, just maybe, a tool for actually healing our planet. You know, every revolution really does start with a simple question. And for the entire Hempoxy project, this was it. This is the question that kicked the whole thing off. Someone looked at our total reliance on petroleum and just asked, hey, isn't there a better way to do this? And that one simple question forces us to zoom out and look at the much bigger problem that Hempoxy was created to solve. The fundamental way we make, well, everything. For over a century, our entire system of manufacturing has been built on a foundation that's proving to be totally and completely unsustainable. For generations, we've been stuck in what's called a linear economy. It's simple. We take resources from the earth, we make something, and then we just dispose of it. It's a one-way street straight to a landfill. The goal now, the big shift, is to move to a circular economy, a closed loop where we make things, we use them, and then we remake them. In this world, materials are designed right from the very beginning to be recovered, basically eliminating the whole concept of waste. So, keeping that circular idea in mind, what exactly is Hempoxy? Well, at its core, it's a totally new kind of high-performance material. You can think of it like a next-gen carbon fiber. But here's the twist. Instead of using petroleum and super energy-intensive processes, its key ingredients all come from one incredible plant, hemp. It's a bio-based resin, kind of like a glue, that's filled with these unbelievably strong microscopic reinforcements that also come from hemp. And the key, the most important part, is that it's built from the ground up for that circular remake model.
Okay, so how in the world do you actually make a material like this? What's the secret sauce? Let's break it down and look at the core components, the sustainable recipe that gives Hempoxy all of its unique properties.
The absolute star of the show is this stuff, hemp-derived carbon nanosheets, or HDCNS. If you think of the resin as the concrete in a building, these nanosheets are like the microscopic steel rebar that gives the whole thing its incredible strength. Now, you've probably heard of graphene, right? This so-called miracle material. Well, making it is often super expensive and pretty harsh on the environment. HDCNS aims to give us similar or maybe even better performance, but it's all derived from a simple crop that actually pulls carbon out of the atmosphere. And the process for making these nanosheets is it's fascinating. It all starts with raw hemp fiber. First, they literally pressure cook it into a carbon-rich goop. Then they activate it with heat, which creates this incredibly porous structure, kind of like a sponge. And finally, that structure is carefully broken apart, exfoliated into individual super powerful nanosheets, all ready to be mixed into the resin. So here it is, the full recipe. The main bio-based glue is epoxidized hemp oil. The natural agent that bonds it all together is modified hemp lignin. The bio-based hardener that makes it all cure and gets super strong is azelaic anhydride. And for that incredible reinforcement, that's where you mix in those carbon nanosheets we just talked about. What's absolutely mind-blowing is that nearly every single key component here can come from the exact same sustainable plant. But here's where things get really interesting. Hempoxy isn't just one material with one single recipe. No, it's a platform, a whole framework that's designed to evolve and tackle bigger and way more complex challenges over time. This timeline really shows the incredible ambition of this project. It starts with version 1.1, which is a 100% bio-based structural material, and that alone is an amazing achievement. But then it gets crazier. Version 1.2 is designed to actively capture waste, like microplastics, and lock them right into the material itself. Version 1.3 introduces true, full recyclability, and the vision just keeps going, all the way to Hempoxy 1.6, a material light enough and strong enough to build habitats in orbit. Seriously?
I really want to pause on this for a second because this is a mind-bending idea. We're not just talking about making a product out of recycled materials. We're talking about a material that is designed as part of its actual function to sequester pollution. It literally turns a liability, our waste, into a functional asset, a useful part of the structure. It's a complete paradigm shift from just being less bad for the environment to being actively good for it. So how is that recyclability in version 1.3 even possible with a material that's supposed to be super strong and rigid? The secret is something called Vitromer chemistry. Okay, think of traditional strong plastics, right? They're held together with the chemical equivalent of superglue. Once it sets, it's permanent. Game over. Vitrimers are totally different. Their chemical bonds are dynamic. Under normal conditions, they're incredibly strong and stable. But when you apply a specific trigger, like heat, those bonds can actually break and reform. That allows the material to be melted down, remolded, repaired, or even completely deconstructed to get all the raw ingredients back. It's wild. Okay, so we've got this incredible, sustainable, evolving, and recyclable material. The huge question is, what can you actually do with it? Let's explore the just massive universe of possibilities. The potential applications are, well, they're staggering. In the near term, you're thinking of things like car panels, construction materials, everyday consumer goods. Then in the midterm, things get more advanced. Lightweight vehicle armor, parts for airplanes, even 3D printed electronics. But the far-term vision? That's where things get straight out of science fiction. We're talking about 3D printing entire carbon-negative houses, creating vehicle bodies that are the battery, and, yep, eventually building those habitats in space.
And underpinning all of this, all these amazing ideas, is a massive environmental benefit. Compared to the old-school petroleum composites, Hempoxy is projected to slash embodied carbon, that's the total emissions for making it, by over 80%. Let that sink in. That's not a small tweak, that's a revolutionary leap. Now, we've talked about the science, the recipe, and all the cool applications. But you know what? Perhaps the most radical, most revolutionary part of the whole Hempoxy project is its philosophy. It's about how this incredible technology is being shared with the rest of the world. The entire framework for Hempoxy has been published openly, for anyone to use. It's something called a defensive publication, which basically means the core science is now in the public domain for everyone. This makes it incredibly hard for any one company to just swoop in, patent the core ideas, and lock the technology up. The goal here isn't to build a monopoly. It's to spark a global collaborative movement. And that brings us to the final thought I really want to leave you with today. We started with a simple question, and we're going to end with a much, much bigger one. We tend to think of progress and environmental health as being in conflict, right? But Hempoxy suggests a totally different path. It asks us to imagine a world where the very act of building, of creating the cars and the homes and the technologies of tomorrow could also, at the same time, help us clean up the waste and the pollution of yesterday. It is an incredibly powerful vision for a truly regenerative future.